Well, hello again, Brainiacs. I figured that today we should probably do a little bit of practice from the lesson that we learned yesterday, section 1.1 of the pre-calc textbook, modeling and equation solving. I'm really just going to be focusing on the equation solving aspect here. So what I've done is I've pulled some questions from section 1.1 that I didn't assign from homework, and I thought that that would be a good opportunity for us to just really practice some algebra skills solving for x. Not to mention, I can also reiterate how to use the graphing calculator appropriately to solve for things that we can't do by hand. Now these we will be able to do by hand, but that doesn't mean that the graphing calculator wouldn't have been an easier method, right? Again, you won't be able to do this on the tests, but going forward in calculus next year, this is a skill that you want to have, solving graphically. All right, so I'm pulling things from section 1.1, like I said. If you have a physical textbook, it's page 77, and I'm just going to be legitimately stealing these questions right from the textbook and working them along with you. So the way this is going to work is when I write down the question, I encourage you to pause the video and try to work it before I do. Or, if you don't want to, if you're not confident enough yet, you are welcome to follow along as if this was extra notes, but that's completely up to you. This is not an assignment. It's just so that way you can see some more things worked out. And then hopefully the homework will be easier if you were struggling with it. Okay, here we go. The first one's going to be number 31 on page 77. 2x squared minus 5x plus 2 equals x minus 3 quantity times x minus 2 quantity plus 3x. Wow, got a lot going on here. Whenever you're solving algebraically, you have to have everything on one side if you're dealing with a polynomial and have it set equal to 0. So because I have x squared here and I know that I'm going to have x squared here, I am going to have to do some multiplication, some FOILing here, and then I'm going to have to bring everything over to one side, bring it over to the left. Also, you may notice that I am using a pencil right now. That is because I don't have erasable pens and I don't want to have to make a whole new video. So I'll be using pencil to hopefully deal with any mistakes that I make, because let's be real, we know I make them. Okay, so FOILing first. X times x, x times 2, negative 3 times x, negative 3 times negative 2. Got ourselves a green crab claw there. All right, x times x gives me x squared. X times negative 2, negative 2x. Negative 3 times x, negative 3x. Negative 3 times negative 2, positive 6. And then, of course, I still have this plus 3x. Now, normally in the FOILing process, I'd be forced to combine like terms right here in the middle. However, I see that there is a negative 3x here and a positive 3x here. So those will instantly cancel each other out. There we go. So simplification, pretty darn easy this time. 2x squared minus 5x plus 2 equals x squared minus 2x plus 6. Now all three of these terms do need to come this way. That way I have a 0 on the right side. So I'll subtract x squared from both sides, making sure to line my like terms up. I will add 2x to both sides, and I will subtract 6 from both sides. Everything on the right side cancels out now. 2x squared minus 1x squared does give me x squared. Negative 5x plus 2x gives me negative 3x. And 2 minus 6 gives me negative 4, equaling 0. We're going to have to factor, but this is one of the easy ones because a is 1. So I don't have to worry about what I like to call the Lizzie step, where I have to do over a in the parentheses. That doesn't happen. Instead, I'm just looking for the two numbers that will multiply to negative 4 and add to negative 3. Those two numbers will be negative 4 and positive 1. And at this point, we're just trying to figure out what would make the insides equal 0, which means just switch your signs that you see there. So I'm going to get x equals positive 4 and x equals negative 1. And those should be our two solutions. Now, there are times when you need to double check the answers to make sure they're not extraneous. That means algebra gave them to you, but they don't work in the beginning. But this isn't one of those times because this was just polynomial in nature. This was polynomial in nature. They had no restrictions on their original domains. So because of that, we know both of our answers will work. So when would you have to worry about something like that? You have to worry about that when you're talking about solving equations that have radicals in them, specifically square roots, because canceling a square root with a square also cancels its domain restrictions. And another special case where that could come up would be rational expressions, rational functions. If you have a x on the bottom of a fraction at the very beginning, canceling said fraction cancels its domain restrictions. And another very special case, which probably doesn't happen very often, is when you're dealing with absolute value equations, if you have x's inside and outside. One of those situations will come up today. Anywho, those are our two solutions. Now we will grab the graphing calculator and go ahead and graph those two equations from the very beginning and see what we get. Turning it on, press your y equals button at the top left, boink. We are going to type this exactly as we see it on the left side as y1 and type this exactly as you see it on the right side as y2. y1, 2, and then remember this is your variable button, x. Down here is your square button, squared, minus 5x plus 2. Scroll down with the down arrow. And we are going to type this exactly as you see it with parentheses. Our parentheses buttons are right here. So we say open parentheses. Where is it? There it is. X minus 3, close parentheses, this is above the 9. Then open parentheses again from above the 8. X minus 2, close parentheses, plus 3x. Remember, this is your variable button. Now, because I don't know what I use this graphing calculator for last, I am just going to hit this zoom key that you can see right here at the bottom of the frame, and then I'll hit the number 6. That will take me to a standard 10 by 10 grid, and let's see what happens. It may or may not fit, I don't know. There's the first equation, and there's the second equation. All right, now as you can tell, we did get one solution right there, but the other one's happening somewhere off screen. So what I'm going to do is I'm going to go ahead and change my viewing window. I would like you to notice that I don't need anything below, say, y equals -5. I really don't need anything to the left of x equals -3. And it doesn't look like I'm going to need anything to the right of x equals 5. I do need a lot more y's, though. So go to my window. X minimum, what did I say, -3? -3, make sure you hit the delete key to get rid of that 0. X maximum, I don't know, 5 or 6. Let's go 5. Scale of 1, that'll work because there's only a distance of 8 between -3 and 5. Y minimum, -10, that's way too far down. How about -5? And press delete to get rid of the 0. Oh, by the way, the delete key, right there. And Y maximum, I don't know how high to go, so how about we go, I don't know, 20? That feels good. And 25 tick marks? Yeah, sure, why not? Graph. Look how pretty that is. 1. Eek, it barely fit, but it's on there. Now, normally we would have to go through the whole process of figuring out where the graphs cross each other by doing second trace intersect. But we know we're looking for integer answers. And this time, because we did algebra and we are so confident in our skill set and the answers are so pretty, I think it's good enough for us to see that yes, they do cross at x equals -1, and yes, they do cross at x equals 4. Now, if we had uglier answers that required the quadratic formula, then I would definitely be testing this with second trace intersect. All right. Calculator off and move on to our next example. The next one is going to be number 33. This one's actually going to be a little bit less work than the first one. That's the entire question. There it is. Again, you cannot solve by hand unless these things are set equal to 0. So we will have to start by distributing and then moving this 12 over so that I get a 0 on the right side. Going to bring that 12 to the left by subtracting it. Of course, these aren't like terms. I just don't have a better place to write that minus 12. And we're always on the lookout for a GCF before we start factoring. But unfortunately, this doesn't have one because there's a 5 here. So none of these numbers have anything in common. They don't all have x's. So for this one, when we go to do our factoring, we are going to do the quote-unquote Lizzie method, and that's because my value in front of x squared is not a 1. So what we're looking for is the two numbers that will multiply to a times c. Our a times c is 2 times negative 12, which is negative 24. And we need those two numbers to add to our b value of negative 5. Now I am going to be going through this slightly quickly, and that's because the hope was that you'd pause this video and try to do all this ahead of me. So the two numbers that multiply to negative 24 that add to negative 5 are going to be negative 8 and positive 3. So I come down over here, two sets of parentheses, x in the front of both of them. The two numbers we just found, negative 8 over positive 3 over what? Over a, over 2. And then if you can, you reduce some fractions. This one obviously reduces. 8 over 2 is 4. This one does not reduce. Leave it as a fraction. Remember, if we were just trying to factor this polynomial and we weren't trying to solve for x, we wouldn't be finished. We would have to take this 2 because we still have a fraction here and scoot in front of this x so that it said 2x plus 3. But since we're trying to solve, the Lizzie method gives us our solutions right there. All we have to do is switch the signs on the numbers on the inside of the parentheses because that is what would give me a 0. That gives me x equals positive 4 and x equals negative 3 over 2. And because this was polynomial in nature with no restrictions on our domains, we know that we don't have any extraneous solutions. So at this point, we just grab handy dandy calculator to check our solutions on y equals. Okay, let's clear those out with the clear button that's underneath your arrows. The left equation is going to be x parentheses 2x minus 5 close parentheses. And the right equation will legitimately be y equals 12. That's just a horizontal line. So we're just looking for the two places where our parabola is going to cross a horizontal line. Now, watch what happens if you hit graph. You see, it used the grid the window that I set up last time. Did I get lucky this time and it actually fit in the grid that's on this window? Yes, I did. I got lucky. But what if we were somewhere else ridiculous because the last question had us graphing somewhere wild? You see, this is why I don't just hit graph. Normally I hit zoom 6. And so just say you're in that habit, you had hit zoom 6. This is what you would have gotten. Oh boy, you see the other line, y equals 12, didn't show up. But you have a brain, you know what went wrong, hopefully. You would have said, okay, that's right. This only goes up to y equals 10, and I'm trying to graph y equals 12, which is clearly larger than what's on my window. So you would press window right there, press window. Your x's were fine. You could see that the parabola was narrow. You know that the y minimum didn't need to be less than negative 10, but the y maximum was a problem. You know you needed to see y equals 12. I like my answers to land in the middle of the screen, so I would have just pressed 20. And negative 10 to positive 20 is a distance of 30. And you can either have all 30 tick marks or you can just type a 3. Usually I just take the distance and divide by 10. And then I hit graph. So this is how I would have done this question. I would not have just hit the graph button. Again, if my answers were ugly, I'd be doing second trace intersect. But my answers are pretty, and I could see that yes, this generally does track down to x equals 4. And yes, this does generally track down to x equals negative 1/2. So we're good there. New scrap paper. Next one's going to be number 35, not negative 35, number 35, which is remarkably similar to number 33. So if you hadn't paused the video before the last one, please pause the video before I do this one and try to tackle it on your own, both algebraically and graphically. Go. Okay, the hope is you paused it and now you're coming back after having tremendous success. Start the exact same way. Distribute that x. And we need to bring the 14 over. So if this is so similar to the last question, why even bother showing it? Well, because it doesn't factor. There are not two numbers that multiply to negative 14 that add to positive 7. It just doesn't happen. So what do we do? Do the quadratic formula. Again, normally I would sing, quadratic formula song, but my voice is already having trouble this morning. So you'll just have to imagine the sweet, sweet sound of my voice crooning a wonderful quadratic formula song. Just have to go over there. Okay. Anytime I fill out my quadratic formula, I do so with parentheses when I substitute. This way I don't mess up anything. What we have here is a equals 1, b equals 7, and c equals negative 14. All right, let's see. We said b was 7, a was 1, c is negative 14, a is 1. I'm going to go back to using pencil just in case I make a mistake. Negative 7. 7 squared is 49. Check this out. This 4 has a minus sign in front of it. That makes that a negative 4. So what I'm actually doing is multiplying negative 4, 1, and negative 14. That gives me positive 56. Alrighty, let's see, working vertically here. 49 to 56, what is that? 105? So typically, at this point, you would start looking for perfect squares that go into 105. The first number that I know that will go into 105 is 5, obviously, because it ends in a 5. But if you divide this by 5, what you get is 21. And 21 is just 3 times 7. So as it turns out, 105 is 3 times 5 times 7. Those are all prime numbers. There are no perfect squares that go into it. So those two values are legitimately our answers. I'll separate them. On my test, they would probably be not separated. They would probably be left like that. And those are ugly. I'm not even going to pretend to know what those values are. I mean, I know that's somewhere around 10, right? But let's see what we get on the calculator. The negative key is all the way down at the bottom right underneath the 3. So -7 plus, if you want your square root symbol, it's right there, but you will have to hit the blue second key to make it pop. I'm going to hit enter right there and then hit divide by 2. So my first answer is around 1.62. And for the second answer, I'm going to do the exact same thing, but this time I'm going to hit minus 100, minus square root 105. You want to see something cool? I'm going to use the up arrow. I'm going to scroll up until I highlight that. I'm going to hit enter, and look what it did. I'm going to scroll left, and I'm going to hit minus sign. Look at that. And then hit enter, and then divide by 2. Negative 8.62. Ish. Okay, there. Clear my screen. Let's get back to the top so we can see what the question was. Go to y equals. Clear both of these. X, open parentheses, x plus 7, close parentheses. And down here, y equals 14. So we're trying to check our answers graphically. So I'm going to use this knowledge right here to set up my window. I know my x-axis needs to go all the way past this number. So -10 works on the x-axis. And it needs to go past this number on the right side. So x equals 10 works there also. My y values, though, I'm trying to figure out where the horizontal line y equals 14 crosses. So for my window, I'm trying to avoid all the lights. There we go. Window. Those x's are fine. I mean, I probably don't need to be anywhere near this number, but whatever. Y equals 20. Yeah, 20 is bigger than 14. You know what? This window ought to work. Let's just hit graph. Okay, we can't see our whole parabola, but not really a big deal. There we go. Now, if you'd like to see the whole parabola, we are going to need to dip down below. I'm just going to go to y equals, and I'll take my y minimum down to, I don't know, -15. And let's hit graph again. There we go. Now we can see the whole thing. We didn't need to, but it's nice to. Okay, so in order to figure out where these things are intersecting, I'm going to need to use this blue command right here, which means I need to use the blue button. Second, calculate. We're looking for intersections. I'm going to hit the number 5. It says, is this one I'm on, one of the two curves? You say yes by hitting the enter key. It says, is this the other one? You say yes by hitting the enter key. And then you either scroll left or you scroll right until you get the answer you wanted to test. I'm going to scroll to the right because that's closer, and I'm going to be honest with you. If we got one of them correct, there is no way we got the other one wrong, so I'm only going to check one of them. We're hoping that that's going to land somewhere around 1.62. Notice that that's not my answer. That's because it's still looking for me to guess where it is by hitting enter. 1.62-ish. That feels good. Shut her off. Number 37 will be the next one that we check. All right. We have enough room at the bottom of this paper here. This math may have to get short. Make sure it fits vertically. Okay, so tricky question, and this is one of the reasons why I did not assign it for homework. You see, the first reaction that students are going to have is that they need to get rid of this square root symbol. And yeah, you do need to get rid of the square root symbol. But the thing is you cannot cancel any symbols in mathematics until they're isolated. I mean, you can, it just takes a little bit more precision and being careful that you don't goof something up. So the strong suggestion is here that you do not try to cancel a symbol until it's alone. What that means is I'm going to move the square root structure to the right side, and this -2 is part of that. Bring that with it to the right. There. Now, just a second ago, I said we are not going to try to cancel this square root structure until it's alone. It's still not alone. There is a 2 in front of it, a times 2. We're going to cancel that by dividing both sides by 2, like that. So we will have to deal with fractions. Oh no, fractions. Not a big deal. There. We are ready to cancel our square root bar. Cancel square roots with squares. This does not create a plus or minus. It creates a plus or minus in the other order when you cancel a square with a square root. So again, fraction being raised to a power, both the numerator and the denominator get this 2. So it gives me x plus 1 quantity squared over 2 squared is 4. All right, well, everybody loves fractions. No, they usually don't. So I'm going to multiply both sides by 4. To get rid of our fraction issue. And because I am running out of space, I'm just going to go ahead and realize that distribution will be required here. And here I am going to have to FOIL x plus 1 times x plus 1. Ran out of vertical space, so I'm going to scooch over here. Green crab claw. X times x, x times 1, 1 times x, 1 times 1. And I said distribute here, 4 times x, 4 times 4. X times x, x times 1, 1 times x, 1 times 1. Again, I'm moving kind of fast because I'm hoping that you worked ahead of me. Of course, you could always pause the video at any point in time to catch up. There we go. And there you have it. Same thing we've been dealing with so far. At this point, we are going to need to bring everything to the left side to get a 0 on the right. So I'll subtract the 4x from both sides. Subtract the 16 from both sides. Like that. 2x minus 4x is negative 2x. 1 minus 16 is negative 15. And thank goodness it factors easily because I am running out of space, folks. The two numbers that multiply to negative 15 that add to negative 2 are going to be 3 and negative 5. So our two solutions are x equals negative 3 and x equals positive 5. Pretty answers. Well, okay. Let's check it on the graphing calculator. Let's see what happens. Pretty confident, right? Let's see. All right, go to the y equals menu, clear this out, clear that one out. Whoops, there we go. Okay, the equation is right there. We're going to type it exactly as we see it. X plus 1 minus 2 square root. Remember where the square root is? Right there. Needs the blue key to work. Second square root. X plus 4. The other equation is y equals 0. So type a 0. That's actually going to be the x-axis, but this is the fastest way to do this. And because my two answers are integers, -3 and +5, that are not too large, and I'm hoping that my y values aren't too massive, I'm just going to hit zoom 6. Interesting. Whoa. That red line only crosses the x-axis. I mean, excuse me, the blue line, there we go, I'm not colorblind, only crosses that x-axis one time. And it's crossing at +5. I mean, we could see that. So one of my answers is correct. This one works. But what happened here? This answer is extraneous. This is one of those times when algebra gave us an answer that does not work. But why did it do that? Is it because algebra is wrong? No, of course not. It's because we broke the domain rules of this. The moment we squared both sides, we got rid of its domain restrictions. This original function has domain restrictions. The very first x that can exist here is -4, which is why the graph has a beginning. But the other quote-unquote intersection would only have happened if this thing continued to go up, but it didn't. See, the algebra doesn't know what the original equation was. You gave this graph more space when you canceled the square root bar. So what you have to do when you have x's inside radicals and outside radicals is at the very end, make sure your answers work when you plug them in. This one's not bad because it was negative. It's bad because when I plug it in, it's going to give me something that's not true. Let's try it. Let's test out x equals -3. If I can find the question. Where is it? Oh man, I went way too high. There it is. Okay. Let's plug in -3 everywhere where we had an x. So -3 plus 1, that's -2. -3 plus 4 is 1. And the square root of 1 is 1. So this is -2 times 1. And I'm sorry, but -2 minus 2 does not equal 0. So that one is extraneous. And if you were to have tested x equals 5, you'd have gotten 5 plus 1, which is 6. And in here you would have had 5 plus 4, which is 9. Square root of 9 is 3. -2 times 3 is -6. 6 minus 6 is 0. So the other one does work. We saw that on the graph. And we just double checked our answers. And I think that's enough. I hope you enjoyed, and I hope that has cleared up any of the questions that you might have from the homework. If it doesn't, please, as usual, feel free to shoot me a reminder. I'll see you soon.